that we can then send. Summary quickly. Number one, since we talk about vertical, we're talking about something going up and down in one dimension. Something going up and down in one dimension. Going up and down in one dimension. All right. Now, if it's going up and down in one dimension, okay, somebody's writing on my board. Please, can you not do that? Because it affects everyone. All right, number one, going up in one dimension. Number two, the only force acting here. All right, please, can we not do that? Please, can we not write on the board? No, it's fine. It's one dimension still. It is still one dimension because we have two dimensions as well. All right? It's not one direction. It is one dimension. All right, thanks for that input, but it is one dimension. There is what you call two dimension as well. All right. Okay. The only force acting on the object is the force of gravity. The only force acting on the object will be the force of gravity. All right. The force of gravity. And since it is the force of gravity, what do we know quickly about the force of gravity? It is a pulling force towards the earth. We're summarizing because quite a number of people missed the first session. Towards the earth. All right? Pulling force towards the earth. And number two, it is a conservative force. We will talk about this word again probably next week when we look at work, energy, and power. It is a conservative force. All right? We will deal with that when we deal with work, energy, and power. So number one, thing about the force of gravity, it is a pulling force towards the earth. And number two, it is a conservative force. All right. And because it's a conservative force, it pulls all objects at a constant acceleration. All right, and because it pulls all objects as a constant acceleration, we use the letter G, which is an acceleration of 9.8 meters per second. And this will always be downwards. G is always downwards. Remember, we're just summarizing quickly. G is 9.8 meters per second downwards. All right. So we have, again, we said, number one, it's vertical. So the person who talked about direction, that's the direction there. Direction is vertical. But in one what? Dimension. All right. So this talks about your direction, and that talks about your dimension. When we get to varsity, you will see what I mean by one dimension. There's also two dimensions. All right. The only force acting on the object is the force of what? Gravity. All right. What do we know about the force of gravity? It is a pulling force towards the earth That's the first thing. Number two, it is a conservative force. And number three, it pulls all objects at a constant acceleration of 9.8 meters per second downwards, irrespective of how the object is moving. All right. Let's summarize. We're just going to summarize quickly. Again, we talked about a projectile. There is a difference between a projectile and a free fall. All right. A projectile is an object. A free fall is a motion. All right. So let's get the difference between the two. A projectile is an object, while a free fall is a motion. Now, what's the full definition? An object that experiences only the force of gravity. All right, a projectile is an object that experiences only the force of gravity, while a free fall is the motion of an object that experiences. All right, my board is acting. Experiences only the force of gravity. Can I just write FOG? Only the force of gravity. Just want to quickly catch people up to bring people up to speed. All right, my time is running out. If it runs out, we're just going to relog in with the same ID. All right, we're not going to change ID, so just relog in quickly. Once you see my, I'll tell you once it's time to relog in. All right. Okay. Whoever that is, please, can we be mindful of what we do? If you are not interested or you feel we're doing something wrong, please leave the group. All right. Okay, so a free fall, the motion of an object that experiences only the force of gravity. Okay. Now, what are the properties of a projectile? Just a few things. Properties of a projectile. All right, number one. Velocity of projectile decreases in upward motion. Upward motion. All right, the velocity of a projectile will decrease in upward motion. So when the object is going up, what happens? The velocity would decrease. Please, can you mute your mic? If there's a question, please just send a message. Velocity decreases. And the reason for that is because as the object moves up, all right, there is a force pulling the object down, which is the force of what? Gravity. Which automatically causes the object to what? Decrease in velocity. Causes the object to decrease in velocity. Velocity decreases as the object moves what? Up. All right? As it goes up, it gets to a point where the velocity now becomes zero. So velocity is zero, and we call that point maximum height. All right, velocity is zero at maximum height. So remember, object is going up with a decrease in velocity. It gets to that point, which is maximum height. All right, because it's We're going to use that for now. All right. So velocity decreases, it gets to 0. All right. Going up, decreases. And maximum height gets to 0. What happens on its way down? 3. Velocity increases. All right. On its way down. And I'm going to say something very important now. Velocity increases on its way down. Now, so we've talked about 3 different scenarios here. Going up, all right, number 1, going up, velocity will decrease. Number 2, at the maximum height, which is also known as the turning point. For those of you that do maths, you will get to see this later on in maths, turning point. And velocity then decreases. But here is one thing that I want us to see quickly. With this 3 motion, there and there, the velocity changes, or velocity change, is constant. The rate of change of velocity is constant. The rate of change of the velocity. Remember, the velocity is changing, but the rate that is per time at which it changes is constant. And that's why we have it as G, and we say it is changing at 9,8. The rate at which it changes is 9,8 meters per second squared. And this is downwards. I'm going to draw something right now. All right. Keep checking. If you have a question, please let me know. Just type in your question. Don't write on the board. All right. But as this goes on, remember we said rate, which means time is involved. So this object actually goes up with time, gets to the maximum height, and then returns again. But what do we know? Time is what? Increasing. Time is increasing. And with that increase in time, this is what we are going to have. I can then have the position time graph. All right, we did send some videos down to the group. You need to check the video and quickly check on graphs. Somebody's mic is on. All right. Now, if I look at the position of the object, we are going to have something like this. Which is basically a parabola. All right, so this is the position. And that is the time. Somebody's confused now saying, but the object was thrown vertically upwards and vertically downwards in one dimension. I'm repeating that word. One dimension. One dimension. Please, whoever that is, I would suggest that you inbox me and then we can talk about the word dimension and direction. All right. You're disturbing people who want to learn at the moment. All right. So we have it in one dimension, although the object is moving vertically upwards and vertically what? Downwards. Now, if we have that, why is it now spreading out when we draw a position time graph? Remember, as it goes up, time of the essence is increasing. So what happens if I throw the object up from here as a reference point, all right, object is going up, which means the displacement of the object from the starting point is actually increasing. It increases, but it's increasing with time, which means at 2 seconds, probably the object is somewhere. At 4 seconds, it is further away. At 6 seconds, it is further away. It gets to a point where we call the maximum height, where the object no longer proceeds. And at that point, velocity, we say, is equal to what? 0. And that is the turning point, which is known as the maximum height. Now, automatically, the object starts coming down. Please note, when it starts coming down, it's moving closer to the same point where we threw the object, which is our displacement now. So what happens? Object is decreasing in displacement, but time is still counting. So after a few seconds, the object is now closer, but time is still moving. And that's why your graph actually curves this way. And at this point, object is back at the same level here. All right, object is back at the same level there with time involved. So the graph becomes a parabolic graph. All right, please note, the graph is symmetrical because it's a parabola. And it's a parabola because we talk about a conservative force. We mentioned that a while ago. It is a conservative what? Force. Now, what happens here is this. This side is symmetrical